Hey, welcome back, physics nerds. We we've already done some problems where I've given you two sides of a triangle and you find the hypotenuse. We're gonna do the same thing now, but you're also gonna find the angle. Getting started, always remember we always start from the original vector, the first vector, okay, from the beginning point to the ending point, and that's our displacement. That's what we're looking for. And always remember our angle in this class will start from the first vector up. Make sure you point up to the hypotenuse. Okay? So we traveled over here, and then that's how far up we went. So this is how our angle should be orientated up towards the resultant. In this case, we're talking about a resultant vector displacement. So here's our displacement resultant right there. And we already know that the hypotenuse of this triangle is using the Pythagorean theorem. So just in this assignment, you can go ahead and plug in without using the guess method. But when I give you word problems, just know that I need to see the guess method, or else you don't get credit. And I've already showed you how the point system works using the guess method. Each one of those steps you get points for. Now, plugging into the calculator is pretty simple too. And I'm going to go ahead and capture mine. Let's see. I'm going to log in. Okay. There we go. There I am. I'm going to capture my handheld. Or not, or so. Okay. I'm logged in now. So as you can see here, that's how I want you to put it in. And then notice what lights up as I enter it. We have the control, and we have our x squared. And if you look on top of the x squared right here, you have your square root. And go ahead and put the number in from there. Okay. And those two numbers are the same ones here, 4 and 9. Okay, yeah, 4 and 9. So we got 4 squared plus 9 squared. And there's our answer. I'm going to go ahead and put it to 2 significant digits already. Actually, nah, I won't. I'm going to go ahead and put it how I would expect you guys probably to do it. You'll put in a couple of answers. If you do not put it in the correct significant digits at first, show me your correction. Okay? No. Show me your correction by showing me what you're changing it to. 2 significant figures. Our delta XR. Here's 1, here's 2. Do I need to round up that 8? Nope. And our units are in meters.
Hi, sir.
Alright, excuse the interruption. And we have meters. And that's only part of the answer. Now we need to find the rest of the answer by finding the angle. I already told you how to find the angle. Okay? So we're looking for theta now. Okay? What about theta? Okay, this needs to be burned into your brain. We have our little cheat sheet. So, katoa. And how do you choose which equation to use? Now, this is what you do. Every time, I'm going to suggest, every time you're given, and you have either given or found out the opposite and the adjacent, I want you to use tangent, but let me show you why. In any equation, as long as you're missing only one variable, you can find it by isolating it. And I'll show you what I mean. Okay. We're looking for our angle, so we're either going to be given, we're looking for the tangent, the cosine, or the sine of that angle. That'll be part of our equation. And the theta will be the unknown. What are we looking for, though? We're looking for, what do we have? Sorry. We're looking for theta. So we have this right here underlined. Now we're looking for we have the opposite right here. We have the opposite. So it's going to be between those two equations, and we have the adjacent, and that's the equation we use. Okay. We have the opposite, we have the adjacent, we need to find the theta using tangent of theta. Originally, tangent of theta, and then isolating theta by itself. So our equation is going to be tangent of theta equals opposite over adjacent. You don't have to write it this way. What I want to see is what your actual value is. Your opposite value is 9 meters, okay, of your opposite side. Okay. Your adjacent side is 4 meters. Meters cancel. Now, we're looking for theta, not tangent of theta. How do you undo tangent of theta? You take the inverse. Tangent theta. Take the inverse tangent of tangent of theta. And you gotta do the same thing to the other side too. The inverse tangent of 9 over 4. Those two cancel. And now we have our theta by itself, giving us 9 over 4. Plugging it in. Now look where I'm taking it from though. What part of the calculator? Okay. It's this button right there. I hit that button right there. It's trig. Okay. And then we're going to go to inverse tangent. Be careful not to go to tangent. Alright. And then I'm going to put in control divide 9 over 4. But before I hit enter, I need you guys to make sure you guys are in the right settings for calculating degrees. So if you look over here on our calculator, okay, we need to scroll up, and we're going to make sure we're in degrees. Now in this case, I'm already in degrees. But if it had an RAD, that means radians. We need to get it out of radians. And what you would do is you push in right at the battery, go down to document settings, and there are options right here for degrees. Okay, we're good there. Oh, let's not go to radians. There we go. All right, and I'm already in degrees, so I'm going to cancel it. But actually, let me show you what you would do. Go to degrees. Go to make default. And then okay. And then you would look up here to make sure you're in the right setting. And enter. There's our degrees. Now, does this answer make sense? That 66 degrees makes sense. You have to make sure it does make sense. And how do you do that? Okay, we got theta equals 66 degrees. All right. Does this make sense? All right. Pause it if you need to. I'm going to erase the page to clear up some space. All right. How would it make sense if these two were the same size? These two were the same size. Okay. That was not right. I'm just going to draw two sides without the arrows. Two sides are the same. What would this angle be? What would that angle be? Knowing that from here to here is 90 degrees, if these two sides are the same size, it's a square. So the angle would be right in between 90 degrees. So 90 divided by 2. This would be 45 degrees. Now, what would happen if, let's see if I can find a feature that can demonstrate this. Probably that one right there. Okay, here's our hypotenuse. Okay, what would happen if the opposite side was bigger than our adjacent? Okay, our angle would get bigger and bigger. Okay, our angle would get bigger than 45. So that's the case here. Our opposite is bigger. Okay, and that tells us that 66 does make sense in the sense that it's bigger than 45 at least. Okay, so keep that in mind at the very least. Keep that in mind. Okay. Actually, let me go ahead and undo all this and bring this back to the problem. And here are the practice problems that I gave you. Okay. And it's run right through them. Okay. I'm gonna go pretty quickly. Here's our resultant. Okay, in this case, since we have deltas, we're looking for delta x r. Okay, delta x r. And we already know how to find it. So, delta x r. Just for the sake of time, let me get the answer to magically appear. Okay, so you already know how to do this part. We're good here. Now, we already know, here's our theta. We start from the first vector up to the resultant. Okay, from the first vector up to the resultant. And here's our theta. We already know we have our opposite and our adjacent. So we're going to use, along with the opposite and adjacent, just like last time, TOA. Now, you don't have to write the whole thing out again and solve it. As long as you have the opposite and adjacent, just go right to the equation. We don't need the tangent of theta. We need the inverse tangent of the other side. And the opposite, make sure that's correct or you'll get it wrong. If you switch it, you'll end up finding the angle on the other side of the triangle instead. And the adjacent is 1.5 kilometers. Okay, kilometers cancel. And our theta is 51.7 to two digits, so 52 degrees. Okay. Now, does it make sense? It is the opposite larger than the adjacent. It is. So, in that aspect, looks like we're good to go. Okay. Pause it if you need to keep it there. I'm going to clear the screen for space. And go on to number 2. And yeah, I want to do it a little bit better than that. Okay. There's our first original vector. Okay, our initial vector. And there's our theta. Alright, and it's the same thing. I'll put the answers up. Pause it now. Do it on your own. And see if you get the answers that I'm about to post up. But before that, make sure we label it correctly. We have velocity in the x direction, velocity in the y direction. So our resultant vector is going to be the resultant velocity now. Okay. If we look here, acceleration in the x, acceleration in the y. So our resultant acceleration needs to be labeled as such. Okay, and we already know what this one is. Okay. Delta x r. And here are the answers. And there you go. I work pretty fast, huh? But you can't do it that fast. Okay, so keep in mind, make sure your angles make sense. Okay, like for instance, this line is 2.3. This is 2.1. So it's obviously not drawn to scale. This line should be longer. Okay, and which is why you should get an angle smaller than 45. Okay, that's a little mistake right there. This line should be longer than this line, and then you'll get an angle smaller than 45 degrees. I do that. Yeah, same thing here. See, same thing here. This one should be longer. This should be actually that's right. No, that also should be smaller than 45 degrees because the opposite is indeed smaller. Okay, but this one makes more sense over here. We have 62 degrees, and the opposite is bigger, so making it larger than 45 degrees. But if you have any questions, you know where to find me. 6:30 in the morning, after school as well.